If you want to launch a mobile app to the entire market, you immediately run into a friction point. Apple and Google do not share an ecosystem. You have to split your focus and build two completely separate products. Going the traditional, native route means hiring one team to write Swift for iOS and a second team to write Kotlin for Android. You are managing two distinct programming languages and effectively doubling your initial development budget before writing a single line of code. The hybrid app model offers a different path. Instead of two separate builds, you write a single codebase and deploy it efficiently across multiple operating systems. This chart shows the financial impact of that unified approach. By eliminating the redundant native team, a hybrid codebase can shrink your overall development costs by up to 40%. This is a strict capital allocation choice. You are trading absolute pixel-perfect platform performance for massive deployment velocity. The goal here is not to declare hybrid architecture the superior option for every project. It is to identify which specific variation of hybrid development matches your exact budget and risk tolerance. Choosing the wrong architectural foundation wastes your development capital and actively sabotages your business model before the app even hits the store. The first approach is the web view, or progressive web app. A PWA uses standard web technologies like HTML, CSS, and JavaScript running inside a native shell to simulate a standard application. This setup gives you instant load times and offline capabilities. You also bypass the Apple and Google App Store gatekeepers entirely, delivering the experience directly through a browser. The trade-off is straightforward. You sacrifice a premium application feel, and you heavily restrict your app's access to complex device hardware. The second approach is framework-based development. Modern tools like React Native or Google's Flutter compile a unified codebase into an application that behaves much closer to pure native code. Frameworks allow you to build fluid user experiences, rich animations, and high scalability for growing B2B or B2C platforms. But look at this 2x2 quadrant tracking speed to market against app complexity. Even with top-tier frameworks, highly complex or graphic-heavy applications will eventually hit a performance bottleneck compared to pure native code. If your priority is maximum speed to market with minimal complexity, the PWA approach is your optimal choice. If you need high application complexity and can accept a medium deployment speed, you should build with a framework. Your initial launch timeline directly dictates whether you should wrap a website or compile a framework. By default, hybrid apps lack direct access to native device hardware like cameras, GPS modules, or biometric scanners. They solve this through plugin dependency. This diagram shows how the unified codebase sends a request, hits a third-party software plugin acting as a bridge, and then finally accesses the phone's hardware layer. This creates hidden maintenance debt. Whenever Apple or Google roll out a major operating system update, that third-party bridge can break. When that happens, you are entirely at the mercy of independent plugin creators to update their code so you can restore your app's hardware functionality. On a broader level, however, that single code base does vastly accelerate standard feature updates and general bug fixes, since you are only pushing changes to one repository. But that ease of maintenance disappears when you encounter platform-specific bugs, like an error that only triggers on one specific, older version of Android. Isolating those specific anomalies is often more complex within a unified hybrid layer because the developer has to untangle how the shared code interacts uniquely with that specific operating system, rather than diagnosing dedicated native code. The 40% upfront savings you gain from hybrid development is not free money. It is a margin you have to actively defend against long-term technical debt. In practice, industries use these hybrid traits to solve specific bottlenecks. E-commerce platforms deploy hybrid code to seamlessly unify the cart and checkout experiences across their website, iOS app, and Android app. Healthcare providers utilize hybrid architecture to deploy and maintain HIPAA-ready, highly secure patient portals across every device format simultaneously. Logistics companies rely on offline-first hybrid trackers. These allow drivers to scan barcodes reliably, even in disconnected environments, without internet access. EdTech platforms apply hybrid models to dynamically sync user progress, quizzes, and video streaming straight from a desktop session back to a mobile device. And the financial sector heavily implements biometric authentication through hybrid plugins, maintaining strict regulatory compliance across all platforms with one central codebase. Hybrid architecture is not a rigid one-size-fits-all tool. It is a flexible utility that morphs to eliminate specific industry friction points. Success here requires you to ruthlessly align your company's current growth stage with a specific hybrid architecture and an external hiring strategy. For the bootstrapped founder segment, your optimal route is a PWA paired with a goal-oriented agency delivery model. This allows you to instantly validate your minimum viable product. Bootstrapped startups must willingly forfeit premium native polish to preserve their most critical asset, runway capital. The growth stage business segment requires a framework-based app like Flutter or React Native, built by a dedicated external development team. This framework investment secures a near-native user interface and unifies the customer experience, making the longer initial development timeline a worthwhile trade-off. Then there is the enterprise operations segment. This logic tree illustrates that enterprise workflows need an enterprise hybrid app built under a strict fixed-scope contract. Enterprise applications must actively sacrifice cutting-edge consumer design trends to guarantee secure cross-department access with highly predictable costs. Finally, consider the performance innovator segment, teams attempting to build augmented reality, spatial computing, or high frame rate gaming applications. This specific segment must completely abandon the hybrid approach. If you try to force heavy processing through a shared codebase, you will inevitably hit a hard performance ceiling and frustrate your users. The ultimate market success of an application does not stem from the elegance of the code itself. It comes from perfectly matching your architectural foundation to the reality of your business objective.